Hello guys, and thank you for watching this video lecture. Today we are going to learn SQL triggers. So we will learn the basic of SQL triggers, their types like after and instead of triggers, and also we will see some use cases and limitations. First, what are the SQL triggers? Triggers are some kind of special stored procedures, and these triggers automatically execute in response to the event of DML, data manipulation language. So what are the examples of DML events like insert, update, delete on a table? Triggers enforce business rules and they also maintain data integrity or they can automate tasks. So triggers run automatically when their event occurs. Triggers are respond to insert, update, and delete operations. MS SQL triggers are row level by default. It means they handle multiple rows via inserted or deleted tables. Triggers can be in form of after, it means post event, or they can be in the form of instead of. It means they replace event and they are used for validation or views. After triggers execute after the triggering event completes, and the use cases of after trigger are logging, updating related tables, or cascading effects. And after triggers cannot modify the data being inserted or updated. Then we have a kind of triggers that instead of triggers replace the triggering event entirely, often used with views or for pre-event validation. The use cases of the instead of triggers are handle operations on views or enforce complex rules before data modification. All right, so let's start coding. Like the previous lectures, our examples are based on the university database schema with 11 tables, like student, takes, time slot, section, course, department, prerequisite, teach, classroom, instructor, and advisor. All right, the first example that we're gonna try here is we wanna add two columns to the student table, like date of birth and age, but we will enter the information for the date of birth only, and using a trigger, the age will be added automatically, right? Let's see what do we have in our table, student. So these are the attributes for the student table: student ID, name, department name, and total credit. So now we're gonna add two new columns, date of birth and age, right? Alter table student, add date of birth, and the type is date and not. Then age, a small int, and also null is okay, right? So let's see. This is no need. Correct. So two new columns has been added, but we want to add only information for date of birth, right? Here, we're going to create one trigger, right? We start creating one trigger. We use create keyword, then the keyword of trigger, and we can add any name, trg underscore update age, right? Doesn't matter. Then on which table? On student table. After insert, update the table, right? So here something happens. When the information are entered by user, the information are not going to be saved into the student table. First, they will be inserted into a virtual table that its name is inserted table, a virtual table. Then trigger will be applied. They will be saved into the student table. So data are entered by the user. They will be saved in a virtual table named inserted table. Then trigger will be applied. Then the output will go to the student table, right? So here as begin and end. These are also keywords that must be there. Again, we set no count on. We don't want to get this information again and again, right? Then here we're gonna update the student table, right? So update from student as S. So update S. And what to update, we want to set age is equal to. So in order to calculate the age, we need to find the difference between today's date and the date of birth, right? So date diff in terms of year. In here, the information before coming to trigger are inserted in a virtual table. So let's join it, inner join with inserted table as I, right? On what? On s dot student ID is equal to I dot student ID, right? So in here, I, the data that is inserted in inserted table, right? Virtual table, and get dates. So once again, here the information are in the inserted table, a virtual table, right? So we want to calculate the age. The age is the difference between today's date, this is today's date, and date of birth that has been entered by user in terms of year, right? Then also we need to check that there must be some date of birth. So is not null, right? If it is null, then we ignore it, right? So let's try. That's correct. Now we need to update our table, right? So select all from student. What do we have here? See, date of birth is null. So we have to update date of birth only. Age will be added automatically, right? Update student. Then in here, set date of birth is equal to case student ID, right? So in here, we need to get the student ID, right? Select student ID from student. All right, so let me copy this one and should be here, right? So this is the condition, and we should add one comma here. All right, so where the student ID is in this list. All right, now we need to add some information for date of birth, right? When one, then for example 1998 05 15, right? Then when two, then for example 1998 6 12, right? Then we will do the same for all. Yeah, we need to add as else, right? Else something. All right, so let's try this one. Correct. Now we go for select all from student, right? So you can see here we have entered only the date of birth, but age has been calculated automatically, right? So in this way, we can make a trigger to automate some tasks. The next example, I'm gonna try one trigger to make sure that classroom capacity does not exceed 200 before insertion. We use this trigger for the classroom table in order to prevent insertion of rows with capacity exceeding some number like 200, and we replace this one with the insert operation with a validation check. Then it will raise an error and roll back the transaction for invalid rows while allowing valid rows to be inserted normally. This trigger is executed before, or more precisely, instead of an insert operation on the classroom table. And this trigger validates the capacity of any inserted row does not exceed like 200 or any number, and this only allowing valid rows to be inserted and reject others with an error. When we want to create a trigger, we should check that this trigger already exists or not, right? So we add one code here, drop trigger if exists. And for example, we say check underscore classroom capacity, right? So we try this one, it's okay. Now we're gonna create a trigger and the same name we're gonna use here. So on which table we will associate this trigger with the classroom table, right? With classroom, right? Then we replace the insert operation to validate data first, right? So we write here instead of insert as begin end, right? Then here set no count on, right? This suppresses row count message to avoid affecting client applications. If we do not use this line, then SQL Server return row affected message for any DML statement, and this may add slight overhead and clutter output in client application. Then if exists, we check if any inserted row has capacity more than 200, right? So we add a query here, select one from inserted. This inserted is a virtual table where capacity is greater than, for example, 200. Then here begin and end. And we want to raise an error here. So error, raise error. And in here we add a message, right? For example, classroom capacity cannot be more than 200, right? And for SQL raise error, we use two parameters, like this is called as severity. 16 is severity and 1 is state. Severity 16 indicates a general user-defined error that is significant enough to stop the current operation but does not terminate the connection. And this one here, this is state 1. This is a user-defined code, typically between 1 to 255, and we use this one to provide additional context or categorization for the error. By default, it is 1, right? Then in here, we cancel the insertion operation because it violates the condition, right? Should be 1E here. All right. So then we will cancel the insert operation. So roll back transaction. In the next lecture, we will study what are the transactions, and then we exit the trigger, right? Then in here, we perform the insert for valid row. So here we check if it is more than 200, but if not more than 200, we have to insert data, right? So insert into classroom. And what are the attributes? Building, then room number, then capacity, right? So we insert valid rows into the classroom table. Then here we select column for insert the table, right? So building, room number, and capacity. Then from where? From the virtual table that contains the row to be inserted, right? First, we will pass those information into a virtual table, and if it's okay, then we will allow that trigger to add to the table, right? So from inserted, this is the virtual table, and then where capacity is less than 200 or equal, right? So this is our trigger. Let's try this one. It's fine. Now let's add some data into this classroom. Insert into classroom, and values are, for example, uh, Watson, then 120 and 50, right? So let's change this one to 1 to 1. It's fine, right? Next time I change it to 122 and change this one to 250, more than 200. So you can see there is one error. The transaction ended in the trigger. The batch has been aborted. And you can see the message here, classroom capacity cannot be more than 200. It will not allow us to add classroom with the capacity of more than 200. In practice, this trigger is saved in the MS SQL database where the classroom table resides, and specifically within the database system catalog like sys.triggers and also sys.subject. And these are a database object, and they are associated with the classroom table in the specified schema. So this trigger check the inserted table for rows where capacity is more than 200. If any such row exists, it raises an error with this raise error that we have here and roll back to the transaction, right? And if it is valid, then it will be added. Next, I'm gonna try one after insert trigger, and this one I'm gonna log every new department insertion into the department log, right? So log refers to the automatic recording of details such as department name, budget, action, and timestamp in the department log table. It means we will have a separate table like department log, and if we do anything, that will be recorded here. When the department log will get a new record, whenever a new department is inserted into the department table as facilitated by the after insert trigger. So here I wanted to find a trigger. So I already did it. So let's show you what I did already. Select all from department underscore log. Department underscore log. So you can see here, finally we will have something like this, right? I inserted my new department, insert, I deleted, right? We want to save whatever is going on here, right? So I will show you how to do it. I will remove it and make it again, right? So here, drop table if exists, and we will gonna remove this one, all right? So we will generate it again. Now we need to create this table, right? So create a table, and we name it as department log. Then in here, what we need to add, log ID, and this is like integer, and identity, it means increment by 1 and starting from 1, right? Automatically, it is auto incrementing attributes, right? And also it is a primary key, so it will automatically start by 1 and increase 1 by 1, right? Then we have depth underscore name, and this is varchar of like 20. So this store department name, and the maximum character is 20. Next, I'm gonna add one attribute to store the budget, right? Budget, and budget is decimal and 12 and 2, right? So this will store budget with 12 digits, and out of 12, 2 are decimal places. Then we will have action, what happened, and this is varchar of 10. This will store the action type like insert, delete, whatever we have. And also we want to store time step of the log entry, right? So we call it as log underscore time, and it is date time, and by default it is the current time, right? Get date. That's fine. So we have generated this table. Then let's see this table, select all from this one. All right. Now I'm gonna generate this trigger, right? So because I already generated this trigger, I need to remove it. So drop trigger if exists. The name of the trigger, for example, log underscore depth, right? That's all. All right, so this is for depth insert. Later we will have another one for depth delete, okay? So then here, create this one, this trigger. On which table? On department table. So we're gonna associate this trigger with the department table, and we will execute this one after insert operation completed, right? So after insert, right? Then as begin end. Then in here, again, set no count on. This will surpass row count message to avoid affecting client application. Next, we're gonna insert into department log, right? Department log, and here department name, budget, and action, right? The rest will be automatically added, right? We will insert log entry into the department log table. Then here, select depth underscore name, budget, and insert. And insert. What this insert is the word that we are gonna add it to our table, right? So in here we select depth name, budget, and statistic action of insert, right? So from where? From the virtual table that contains the newly inserted rows, right? Inserted. That's fine, and that's okay. That's finished, right? So let's try this one. Here I need to add a trigger. That's fine. Now I'm gonna add a sample department to the trigger login, right? So insert into department depth name, building, and budget, right? Now values are, for example, new AI1 science hall, and the budget is this one. That's fine. Let's insert into. All right, correct. Now I should see my log, right? This one. So you can see here. So why 2 times? So let's see how many triggers we have in this name. Select all from sys.triggers, and the name is equal to this one. We have only one trigger here. So one case is maybe I have already another trigger with this table, right? All right, so let's try again with new name. So let's make it like for 2, right? Create table 2, then from 2, it's fine. Then insert 2, it's fine. Then 2 here, and we call rename it as 2. That's correct. And this one, that's correct. Then this one, we will see what happened. You can see here, new AI4 has been inserted as a new department, right? Now I'm gonna add the same thing for deleting, right? This one for insertion. I wanna add deletion also as well. So I need to make a new trigger here. So I will revise this one, and I'm gonna call it as log department and delete, right? Then on department, after this one should be delete, and then again same department log to department name budget action, then this one should be delete, right? And from the deleted. All right, so this is the trigger completed. Now to check this trigger, so I'm gonna delete the one department, right? So select all from department, and but we added newly, so we have new AI4, right? So I want to try to delete this one. Delete from department where depth name is equal to AI, a new AI4, right? So let's try this one. Correct. Now let's see what do we have in this table. You can see here we have 2 actions, insert and delete. So in this way, we can log insertion or deletion on this table. The next one that I'm gonna try is an instead of update trigger. So we wanna try to prevent salary decrease for instructors. We want to prevent an instructor's salary from being decreased in the instructor table. All right, so let's add some new professor. Insert into instructor, and then in here instructor ID, name, department name, and salary. And the values are for example I8008, and the name is Jack, and the department is new AI1, and salary is 70,000, right? So let's see this one. That's correct. Now we want to create a trigger to prevent salary decrease in the instructor table, right? So create trigger and we name this one as salary no decrease, right? That's right. On which table? On instructor table after update. This time update, right? So we associated these triggers with the instructor table, and this trigger will be executed after the update operation and any cascade action. It means some other table has been changed, but by cascade, this table is going to be updated, right? So as begin and end. Then in here, again, set no count on. So here we have to check if any updated rows have a decreased salary, right? So if exists, what to exist in here we define, right? Select one from inserted that has been in new data after update, right? This is temporary or stored in inserted table. So as then we do inner join with deleted as d on i.instructor id is equal to d.instructor id. So all data before update we join on instructor id, okay? Then where i.salary is less than d.salary. In this way we can check and we can identify rows where new salary is less than the old salary, right? So if something happened like this, then we have to raise an error, right? So begin and end in here, we need to raise an error with instructor ID of the first offending row, right? So declare instructor underscore ID as varchar 5. Then in here, we select top one, right? That one has been changed. Top one at instructor ID. Instructor ID is equal to I dot instructor underscore ID, right? Then where the condition is I salary is less than the salary, it means has been decreased, and we raise an error and we message that salary decrease not allowed for instructors, right? And it will be in string. So it will be a dynamic error message, and again 16 one and instructor underscore ID, correct? Next, we will cancel the entire update operation. So roll back transaction, and then we exit the trigger to prevent further processing, right? And after that, we don't need to do anything else, right? Just one error will be raised, right? This one should not be here. So some problem here. Oh, I forget here. Here should be from inserted, the virtual table that we inserted the data. Then in here, inner join with deleted, and we name it as d on i.instructor id is equal to d.instructor id, right? Their salary. So let's try this one. Okay, correct. Now we're gonna try this trigger. We try to increase salary, right? So update instructor and set salary is equal to, so let's see, select all from instructor. So for this one, and name is equal to who, right? Set salary is equal to 95,000, where instructor ID is equal to 12121, right? 12121. So let's try this one problem. Correct. Now let's see his salary. It has been 95,000, so it's fine. Okay. Next, I need to decrease, right? So update. We want to see whether our trigger works or not, right? So update instructor, right? The same, but this time I want to change it to again. I want to change it to 85. So let's try this one. There is an error. Salary decrease not allowed for instructor. This instructor, right? So I add one mistake here. Instructor, right? So drop this one, then create this one, then you can see here salary decrease not allowed for this instructor. So in here, let's change the department name. Let's see whether this trigger works for other attributes or not, right? So for example, department name is equal to, what is his department name right now? who is finance, right? So let's change it to new AI1. It's correct. So there's no problem, right? So for this one, there is no problem. So it has been changed to new AI. Okay, that's all for today. Triggers are not easy to work with them and they are hard to debug. Another problem is the row level triggers slow down bulk operations and the triggers cannot be called directly or parameterized. Triggers can cause unintended effects, and we need to test all DML scenarios. And also, if we design these triggers not in the correct format, they can raise a lot of errors. So we should avoid complex logic. We should use stored procedure for complexity. We should clearly comment purpose and logic. And also, we should cover edge cases and bulk operations. We should care of the triggers modifying the other tables. Okay, so in conclusion, triggers in MS SQL are powerful for automation, validation, and data integrity. We use instead of triggers for pre-event validation, and also we can use after triggers for post-event actions. We should care about design and testing in order to avoid complexity and performance issue. Thank you very much for watching this video lecture. Please practice them and feel free to ask me your questions by leaving a comment below this video lecture. Thank you and see you in the next lecture.